So hopefully you've had a chance to try these problems. So I've got 1 log right here, base 7 of this fraction. And I can see that fraction actually has 3 parts. There are 2 things multiplied together on top, a number and a variable x, and then I've got the bottom y minus 1. I know that inside of the argument I can't simplify any addition and subtraction. So this is going to become a sum and difference. The 2 factors on top get a positive log. So I'll have the log base 7 of 2 plus the log base 7 of x, and then viewing that as 1 factor on bottom, that gets a negative log. So minus the log base 7 of the quantity y minus 1. Now I do want to take a look at this one because this just involves numbers. I want to see, could I simplify that? Not nicely, because 2 is not a power of 7. Okay, so that's as simple as that one's going to get. Now here, I wanted to combine things into a single log with coefficient 1. So we'll have the log base 2 of a fraction. And basically, if it was a positive log, it goes on top. If it was a negative log, it goes on bottom. This was a positive log, so we're going to have a factor of x plus y on top. And remember, I can't simplify that addition inside of the argument. Okay, we were subtracting this log, so we'll have a 5 on the bottom. And then we were adding this log, so we'll have a z on the top. Okay. Now, if I wanted to simplify that by distributing the z, I could certainly write this as the log base 2 of xz plus yz over 5. Just do that multiplication. It's generally considered simpler if you don't have parentheses. So that would be a step that you should do. That's going to give me something that's going to simplify that basically as much as it can. Okay, so far we've learned 2 rules of logs. We've learned the product rule and we've learned the quotient rule. Adding logs corresponds to multiplication, subtracting logs corresponds to division. We have one more important rule of exponents that's going to give us a corresponding rule of logs. And that has to do with when I have a power to a power. So if I had x to the m, or sorry, let's go with a base of b to the m to the p. When I have a power to a power, I can multiply the powers, so I can say that's b to the m times p. Now, that is multiplying exponents, but it's not going to correspond to multiplying logs with the same base, because notice the base for p is b to the m, but the base for m is just b. So they're both exponents, but they have different bases. Okay. I'm going to once again let x be b to the m, so that I can say that m is the log base b of x. Okay. And then what we're saying here is that, so that's x, so this is basically x to the p. Okay. So here we're saying that mp, that's the exponent I need when b is my base to get x to the p. Okay. But notice that's just the log base b of x, that's what m is, times p. Now what I'm going to do is, rather than writing the, times p, usually the way you'll see that written is so that we don't need to have these parentheses here to make it clear that it's not the log of xp, but it's the log of x times p. Usually we'll write that p first. So we'll have the log p times the log base b of x. That's the corresponding rule of logs, that the log base b of x to a power is p times the log base b of x. So it basically allows me to move around that p. So I can take that p and move it down to make it a coefficient, or if I have a coefficient of p, I can move it up to make it an exponent. Okay. So let's see how we can use that rule. Let's try this, writing in expanded form. Let's try the natural log of x squared y cubed over z to the fourth. So what we're seeing now that we didn't see before is that we've got some exponential expressions inside of the argument. Okay. Now, the first thing I would do is use the product and quotient rules for logs that we've been doing. I'm going to go ahead and use my shortcut. I'm going to basically say I've got three factors here. I've got the x's, the y's, and the z's. So if it's on top, it gets a positive log. If it's on bottom, it gets a negative log. So this would be the natural log of x squared plus the natural log of y squared minus the natural log of z to the fourth. But if the rule for expanded form is that I want my arguments to be as simple as possible, so I always want to have just a single number or a single variable or occasionally a single addition or subtraction problem because we can't simplify those things, I don't want to have this power here. So I'm going to use this power rule that says each of these exponents can come down and become a coefficient. So this is going to be 2 natural log of x plus 2 natural log of y minus 4 natural log of z. Now those arguments are as simple as I can make them. Okay, excellent. Let's try another one. Still writing in expanded form. Let's say I wanted to take the log base 3 of the square root of x cubed y over z plus 1. Now here, I need to be very careful. I want to remember that I can rewrite roots as powers. And I want to do that. I want to rewrite it as a power so that I can use my power rule. Okay, so this is the log base 3 of, we would have this quantity, x cubed y over z plus 1, all raised to the 1/2 power. Now, that exponent of 1/2 applies to everything. Okay, so I can deal with this one of two ways. I could distribute that over the multiplication and division. So I could make this the log base 3 of x to the 3/2, y to the 1/2, and then it would be z plus 1 to the 1/2. Remember that exponents distribute over multiplication and division, but never over addition and subtraction. Okay, that's one option. The other option is that I could bring that 1/2 down in front right now before I break it apart. If I do that, I'm going to have to, at the end, distribute that 1/2 back in. Let's actually do it both ways. Okay, so let me just keep going with this. Now I would use my product and quotient rules. So I would say that this is the log base 3 of x to the 3/2 plus the log base 3 of y to the 1/2 minus the log base 3 of z plus 1 to the 1/2. And now I can use my power rule. Each one of these powers comes down and becomes a coefficient. So this will be 3/2 log base 3 of x plus 1/2 log base 3 of y minus 1/2 log base 3 of z plus 1. And now all of the arguments are as simple as they can get, just a single variable in those places and a single addition problem that can't be simplified. Okay, so that was distributing the exponent over the multiplication and division first. Okay, my other option I mentioned would have been that because this applies to the entire base here, I could have brought it down in front of the log. So I could have said this equals 1/2 the log base 3 of x cubed y over z plus 1. Okay. Totally fine, but then that 1/2 will apply to the entire thing when I break this apart. So it would be 1/2 times the quantity, log base 3 of x cubed, plus log base 3 of y, minus log base 3 of z plus 1. Now, this one can be simplified further because I can bring that 3 down. Here, the argument is as simple as it can be. Same here. So now I would have 1/2 times the quantity 3 log base 3 of x plus log base 3 of y minus log base 3 of z plus 1. And then I would want to just distribute that 1/2. So we'll have 3/2 log base 3 of x plus 1/2 log base 3 of y minus 1/2 log base 3 of z. Same answer we got the other way, just depends on what you see first. Okay. All right, so I'm going to have you practice one of these, writing things in expanded form, and then we'll start trying to go in the opposite direction and write things as a single log with coefficient 1. So I want you to try writing in expanded form. This is one from the homework. It's 35, so you're getting a jump start on the homework here. Write in expanded form the natural log of the cube root of xy over w z squared. Now do be careful here. The cube root applies to the x and to the y, but not to the w and the z squared. Okay, so see if you can write that in expanded form. We'll start the next video going over that example together.